Welcome to today's webcast, Wastewater Surveillance Target Expansion and the Need for Higher Order Multiplexing. A special thank you to today's sponsor, Bio-Rad, and thank you to our presenter, Dr. Sarah Kane. Dr. Kane received her PhD in cell and molecular biology from Colorado State University. In her current role at GT Molecular, Sarah oversees product development, wastewater testing method development, and intellectual property ideation and development. Sarah maintains a passion to communicate science to broad audiences and promotes data generation that spurs action. And Sarah, I will now turn it over to you. Thank you.
Awesome. Thank you, Larika, and thank you all for taking the time out of your busy days to attend today's webinar. I feel very fortunate to be able to present to you guys all of the work that we've done at GT Molecular surrounding wastewater surveillance, and then also discuss the next phase. So as far as the outline for today's talk, I kind of wanted to set the stage with a little bit of a historical context and background on wastewater-based epidemiology, and then also outline the COVID-19 pandemic as a case study for the benefits and utility of WBE using data that was generated at GT Molecular. At the end of the talk, I will outline the next phase of wastewater surveillance guided by the CDC and explain the need for higher order multiplexing afforded by the Bio-Rad QX600 platform. And so before we dive into wastewater testing and surveillance, just wanted to kind of give you guys a brief introduction to the company that I work for at GT Molecular. So we are located in Fort Collins, Colorado. The company started in 2018 with a mission to improve human health, and this is achieved by a few different ways. So we have experience with wastewater testing through an internal testing service where we monitor for various pathogens such as SARS-CoV-2, influenza, RSV, etc. And we also commercialize digital PCR kits for other labs to use for wastewater surveillance. Also, the lab has a passion for minimal residual disease monitoring and cancer, and that's actually how we started out with our expertise in digital PCR, and then we adopted the ability to develop digital PCR assays to wastewater surveillance that ultimately culminated in the contract that we received from the CDC to basically develop their assays for digital PCR platforms. And so at the end of the talk, I'll kind of prioritize discussing the next phase and why we need higher order multiplexing. Okay, so as far as setting the stage for the history of WBE, wastewater-based epidemiology actually dates back to Philadelphia in the 1930s and 40s, when a group of medical doctors were trying to understand the transmission patterns of poliovirus. Importantly, this was a time before modern wastewater treatment, and untreated wastewater was discharged directly into rivers and streams. And these images on the slide show sewage drainage pipes discharging sewage into the river directly across from a pier where children and other people often would go swimming. And at this time, doctors John Paul and James Trask, they suspected that polio was shed into feces and experimentally showed transmission of polio from feces. And so from this work, Dr. Paul is actually considered the father of wastewater-based epidemiology. So as you can imagine, a lot of pathogens end up at the wastewater treatment plant. So skin pathogens such as Candida auris, for example, or Mpox can be found in the wastewater by these pathogens being shed into the bathwater. And various respiratory and gastrointestinal pathogens are shed into feces and urine, and they can also end up in wastewater. But a pathogen must have a few characteristic requirements before being considered as a target for wastewater-based epidemiology. Firstly, and probably the most obviously, the pathogen must be shed in a way that ends up in the wastewater stream. Secondly, the pathogen must be shed at high enough levels for us to be able to detect the pathogens from the wastewater treatment plant or other sampling locations. And thirdly, the pathogen infection must have enough prevalence within a community so that you can actually obtain enough of the material in order to monitor it. So importantly, Dr. Ali Bain out of Stanford and her group, they showed that various respiratory pathogens are detectable from wastewater. And this was a great publication that I just wanted to point out in case anybody's kind of curious, like I was, of how, these traditionally respiratory pathogens can end up in wastewater. And so again, just kind of summarizing what I've presented so far, there are a lot of different pathogens that can end up in wastewater and can be viable targets for wastewater-based epidemiology. And while the field of wastewater testing has been around for quite a long time, the COVID-19 pandemic shone a big bright light on wastewater testing's benefits and uses to understand community-wide disease prevalence and spread. So as an example, SARS-CoV-2 RNA was found in sewage from a community in the Netherlands 6 days before a confirmed case was observed in the clinic. And after that, various academic and public health and industry leaders noted that wastewater testing could provide communities an early warning system that can help prepare hospitals and medical care providers so that they could be aware that there is a surge coming. And I will also provide some interesting data later in the talk that outlines how wastewater testing can provide a means to monitor pathogens for atypical seasonal activity. So as an example, we traditionally test folks for influenza and RSV during the um, fall and winter months. However, wastewater testing can be an ongoing way that you can continuously monitor for these sort of atypical activities. Okay, so before we go into any data, I wanted to um, provide a little bit of a brief method slide for what happens in wastewater testing. So first, after a sample is collected and shipped to our testing laboratory, the very first thing that happens is that we spike in a known quantity of an internal process control. And this control essentially serves as a proxy for your target of interest. So you can monitor things such as viral loss with extraction efficiency differences or human error. So that way, at the very end result, you can normalize to this recovery of your internal process control. So after we spike in that internal process control, we have to concentrate the viruses. As you can imagine, a wastewater influence sample is very dilute after all of the flushes and baths that are and showers that are taken. So we need to make sure that we concentrate the viruses or pathogens or targets of interest so that we can detect it at the very end. We then extract out the genomes, whether that's an RNA virus in the case of SARS-CoV-2 or DNA in the case of bacteria, and we extract out the nucleic acids before we run Droplet digital PCR on the Bio-Rad QX600 platform. And then the results using digital PCR are absolutely quantifiable, which means that we can set up the run and then receive copies per microliter out of the instrument itself. And then we can back calculate what that means in terms of the starting material copies per liter. And so the reports that we generate and provide to our customers have copies per liter, quantification values, recovery values, as well as making sure that our PCR ran clean and efficiently. And I just wanted to provide this data as a very powerful data set that outlines what wastewater testing can provide. And so the blue line represents the average nationwide wastewater data set that we generated since like the early stage of the pandemic when we got involved in this field. And then in orange, you'll see average clinical results nationwide. And what I really want to emphasize is the strong correlation between what we see in wastewater and what gets reported in the clinic. And so you can imagine that wastewater essentially is analogous to going to each individual person, collecting a sample, and then averaging the results. And so you guys can imagine that that's going to be a pretty expensive endeavor to undertake. But if you wanted to take wastewater from a specific community, it has a natural averaging sample type, so that you can essentially have data from all of the people of that community. And it's also anonymous, so people don't have to worry about being discriminated against. You can't say that Sarah Kane provided X number of viral particles to the wastewater. You cannot identify a person from wastewater testing. And so it's a very powerful tool and very economic means to understand what's going on in a community at a given time. And so soon after our successes with SARS-CoV-2 and the COVID-19 pandemic, we quickly realized the power and the utility of wastewater testing. And we wanted to expand our target menu to other respiratory pathogens first. So this is a real wastewater sample data from our testing service, where we were able to detect SARS-CoV-2, influenza A, and RSV at the same time from one sample. And so something that's really important to note is that in order to obtain all of this data from one wastewater sample, we had to run this sample in 3 separate reactions. And so to get to the punchline, what we're hoping to move towards next is the ability to merge all of these assays into one reaction so that we can co-monitor all of these pathogens at once. And as you can imagine, trends over time is one of the most valuable data sets that you can generate from wastewater surveillance. And so this, again, is one location from our internal testing service that we provide data for, monitoring RSV, influenza A, and influenza B. And so as you can see here in October, so the traditional sort of onset of respiratory season, we saw a spike of RSV, influenza A, and influenza B. And the activity was, somewhat mild for the rest of the winter months. But what's really interesting to note is that RSV has this atypical pattern in the spring months of 2023. And so, again, a lot of clinics don't monitor for RSV in these, non-traditional months. And so we propose that wastewater surveillance provides an economical and very rapid means to monitor these pathogens for atypical activity. And to explain these results, there have been several reports of this exact trend from the CDC and among others. And what we think happened was that all of these social differences that happened in COVID-19 may have impacted the seasonality of these traditional respiratory seasons. And so again, wastewater is a very tractable sample type to monitor these pathogens. Okay, so I alluded to this, pretty early in my talk. So I just wanted to provide some great feasibility data from Lexi on my team, where the main goal was to convert our current 3 reaction setup into a single reaction. And what we need to, in order to do this, is using an instrument that has multiple channels. So the capability of monitoring simultaneously multiple pathogens using different fluorophores. And so on this slide, we have SARS-CoV-2 over here and rocks, bovine coronavirus, which is our internal process control that serves as our proxy, and ATO 590. Influenza A is in FAM, influenza B is in HEX, and RSV is in Sci5. And so you can imagine the wealth of information that we're able to monitor from a single well. And a huge benefit of this is that we're going to be able to save 67% on consumable costs just by merging what we used to have to do in 3 reactions down into 1. And so our next steps for this are to ensure that all of these targets and these master mixes and platforms are compatible with wastewater matrices, which, stemming from our other successes on the Bio-Rad platform, we don't think that we'll have any issues with that. So we're hoping to have a validated, commercially available assay within the next 4 to 6 weeks. Okay, so I also alluded to this as well earlier. So the CDC came up with their list of targets of interest for the next phase of wastewater surveillance. And as you can see on the right-hand side, this 30 target panel is comprised of antimicrobial resistance genes, upper respiratory pathogens, gastrointestinal pathogens, and pathogens that are considered, and AMR targets that are considered as emerging threats. And so I did a little bit of just kind of back of the envelope calculation. And if we were to use a duplex, so it's just a 2-color instrument, we would basically need to take the same sample and process it 4 times. If again, we were restricted to just 2 channels. But with our ability to higher order multiplex on the Bio-Rad QX600 platform, that brings us down to 1 to 2 preparations per sample. And that means that we can monitor for all of these pathogens from a single sample. And so, before we start talking about, having that readily available, we also have to make sure that we have the appropriate wastewater testing workflows. So there's a lot of nuances with different concentration methods, different extraction technologies, making sure that what you choose to do is compatible with all of these targets. And so I have a couple of people on my team, and I know that the CDC is also working on this as well, to identify not just assays and formulations for assays, but the actual methods of wastewater testing that users can use in order to monitor all of this, this large panel of targets for the next phase of wastewater testing. And just as a caveat, all of these are subject to change. We've been working with the CDC for about a year now. Everything is going really well, but this is subject to change at any time. So this is not by any means like the absolute final formulation or design panel. Okay, so for today's webinar, I have 2 punchlines. One is that wastewater testing provides a powerful epidemiology tool. I don't believe that wastewater testing is going to replace traditional epidemiology using clinical data. I don't believe that at all. I really believe that it's going to be a complementary tool because instead of having to obtain data from each individual person, wastewater represents an average of the entire community. And again, it's complementary. It's not going to replace clinical epidemiology. We believe that this is just going to be a complement. And wastewater testing, again, is anonymous, and it resists, it circumvents any sort of resistance to seek medical care. And ultimately, it's an economical and passive means to monitor for atypical pathogen activity, such as RSV that I showed you before. And as a human being, I can tell you that my daughter got RSV in the spring, and we were so confused, how she got RSV, and it took a couple visits to the clinic in order to identify it. But as soon as we saw the wastewater data, I just had that kind of aha moment of, yeah, there's some atypical activity going on. And I'm so glad that I'm in the wastewater testing field and that we can provide that kind of data to communities. And the second message here is that wastewater testing isn't going anywhere. The CDC believes that this is very useful and beneficial data sets that are generated. And the next phase of wastewater-based epidemiology will benefit from additional multiplexing. So the CDC, again, devised that 30 target panel. And in my mind, in order to implement this panel into our current testing paradigms, we really need to consider how we can multiplex to get a lot of information from a single well, from a single sample, without having to take the same sample and process it, 17 different times. Okay, so I just wanted to provide this as a contact us. If any of you have any sort of questions or wanted to dive into anything a little bit more in detail that I presented today, please feel free to reach out to info@gtmolecular.com. Again, we have an internal testing service operation that includes quantification on the Bio-Rad digital PCR systems. We also have NGS services. And then also we equip other fellow wastewater testing labs with our digital PCR kits, and we have some surveillance guides. If anybody has any issues implementing their actual workflows, we have your back, and we have an amazing technical support team. So we also have logistics offerings as well for sample collection kits. So yeah, more than happy to help out in any way. Please feel free to reach out. And as you can imagine, this represents a lot of hard work from a lot of people at GT Molecular, our internal testing service, R&D, bioinformatics teams, our manufacturing team, just everyone at GT is great to work with. A particular thanks to Lexi and Jim for generating those QX600 data sets and for helping us merge all of those assays into one. We have a lot of collaborators, our local Colorado State University. We have wonderful wastewater treatment facility operators that we collaborate with. Thank you to Bio-Rad for sponsoring this webinar. Thank you to WEF for hosting. Thank you to the CDC, and thank you to you all. Really appreciate your attention, and I am looking forward to answering the questions that you may have generated during the time. Okay, let's see. Okay, so it looks like Shireen wants to know which AMR gene targets we are working to develop for wastewater monitoring, and there is a lot. So we have a lot of beta-lactam resistance genes, vancomycin, colistin resistance, and again, these are all under the guidance of the CDC, and it represents a pretty big chunk of the panel. So happy to take that offline and kind of show you our list if you're interested in, knowing of course that they are subject to change by the CDC. Okay, and then David was wondering what concentration methods and kits do we use for collection and extracting of viral and bacterial targets? And that is a wonderful question, and it's very nuanced. So we've seen that a lot of folks use the Series nanotrap particles, and we collaborate with Series all the time to make sure that our digital PCR kits are compatible with the concentration methods that they have. So they have their microbiome A particles, for viral targets in general. And they also have their microbiome B particles that are that capture a lot of different fungal species and some bacterial species as well. And so really our extraction kit is tailored to the concentration method as well. So with viral targets of Series microbiome A, we have MagMax extraction kits from Thermo. We often feel very comfortable using the QIAGEN All Prep Power Viral kits. The Kaya AMP kits from QIAGEN work pretty well too. But as soon as you start talking about, bacterial and fungal targets, we definitely have shown that bead beating is critical. So really, at the end of the day, David, I think it is kind of fine-tuned and tailored to what your target panel is. So I'm happy again to take that offline and have a full-blown chat. We also make sure that our kits are compatible with NovaPrep and Promega as well. So David, I'm not sure what concentration concentration method you're using, but definitely happy to help and kind of riff with you if you'd like. Okay, and then Susan asked, am I working with any local clinical epidemiologists to determine if there is clinical correlation seen in the community? And that is a great question. We have discussions with EPIs all across the US. And what's interesting is that, let's see, I'm not sure if I can go back. So let me just give me a second. Let me go back to this data set. So I really emphasize the tight correlation between wastewater and clinical data, but you can see that that kind of that breaks at a certain point in 2023. And what we think happened here in 2023 is, people weren't seeking clinical visits very much anymore. And also a lot of people were doing at-home tests. And so the reported clinical cases stopped being a perfect match with what we saw in wastewater. And then this trend also holds up with other pathogens such as RSV and influenza, because what we've seen is that the clinical cases are likely underreported. So again, I think it's really important that this is a complementary approach, not replacing. And at the end of the day, we absolutely have to talk with our epidemiologists to make sure that the data that we're generating is relevant and actionable. So sorry, that was a really long-winded way to say, yes, we do work with EPIs. very closely. And I think that that's one of the most powerful aspects that happened in COVID-19 is sort of like the major collaboration between industry and academia and public health. It's been a pleasure. And then Johnny Myers asked, what about Hawk's Cepheid Gene Expert? So I have to admit, I'm not familiar. I have not tried them. If there is a case for us to give it a try, I'm more than happy to. We feel pretty comfortable with the various workflows. So it's certainly something that we can test for compatibility. Johnny, I'm more than happy to chat. Okay, let's see. Oh, so C. auris detection. Um, I don't want to mispronounce your name, so I'm sorry. Is it Jayazima? I hope that I pronounced that correctly. So C. auris was something that kind of made me a little confused for a while because we had wastewater samples that we knew were positive because there were just a large amount of clinical cases in the area. And then we were trying out all of these different concentration and extraction workflows. And then I actually met with a couple folks down in Las Vegas and chatted, and asked, what is your approach? You guys have successfully detected it. And what it came down to was the workflow. So we found, and we have a cute, that's cute, sorry, we have a nice app note I can send to you that essentially shows that what you can do is you can take an influence sample, pellet it at 3,000 times G for 30 minutes, and then beat the pellet. And that has amazing C. auris recovery. So it's actually a pretty simple and straight workflow that I wish that I would have thought of myself. But yeah, huge thanks to the collaborators in Nevada who kind of steered me towards that direction. So yeah, again, happy to share the app note with you if you would like. Okay, so then Kyle asked, how did we come to use the Bio-Rad QX600 versus other digital PCR machines? And did we notice any issues optimizing assays to eliminate rain? So our internal testing service has always used the Bio-Rad QX200 platform, and we've worked with Bio-Rad for, since the beginning. Even before we got into wastewater testing, we were using the Bio-Rad system. And then it was a natural evolution of, we have a lot of successes monitoring SARS-CoV-2. What else? And then, okay, so you can detect flu and RSV, you can detect mpox. We want to start being able to multiplex. And so we chatted with Bio-Rad as they launched the QX600, got an evaluation of their instrument, and eventually ended up purchasing the instrument as well. And, the question is about optimizing assays to eliminate rain. There's always some tips and tricks and tweaks that we do within the R&D context in order to do so. Specifically, if you are trying to eliminate rain, the easiest and most straightforward approach that we've taken is to increase your cycle number. It sort of cleans up the rain, takes any of those intermediate droplets and forces them to be a little bit more higher on the fluorescent amplitude axis. So that's a first thought that I have for eliminating rain. And again, Kyle, if you'd like to jump in on a call, more than happy to. And then as far as sending us the workflow, I have, please feel, let's see, I'm going to provide that email address, and our application sales and technical support team can absolutely discuss with you sending the surveillance guide. We have some for our Nova Prep for series. We also feel very comfortable with the Promega workflow as well. So we provide a step-by-step protocol. So yeah, feel free. Okay, so Joel wants to know, do we think the field is at risk of developing less useful testing infrastructure by relying too strongly on SARS-CoV-2 data, which appears to be an extremely strong and stable signal in wastewater compared to other viral or rare targets? Man, this is the kind of thing that keeps me up at night. And it's why I had at the beginning, things that we have to consider before we consider a target as a viable sorry, I kept saying target. I'm going to say target again for wastewater testing, right? So it needs to, in addition to the 3 features that I had listed, you're bringing up a great point. It needs to be stable in the wastewater stream. And I will be completely honest with you, I was amazed at how stable SARS-CoV-2 was in wastewater influent. we can still detect it a couple years later in our testing lab. So yeah, I think that there's all sorts of nuances to consider based on your target of interest, the stability of the genome, the stability of the intact pathogen, all kinds of things. And so, what we do at GT is we do stability studies. We look for degradation from the same sample over time. And, I think that these are really important studies that need to be done as we expand our target list beyond SARS-CoV-2. So this is a great point that you're bringing up, Joel, and I appreciate that a lot. Okay, and I am actually absolutely happy to drop my email address here in the chat. So it's skane@gtmolecular.com. I hope you guys can tell I really love my job. I love chatting with folks. I love helping people implement wastewater testing into their lab. Even though I'm the director of R&D, I still do on-site visits. I've done a lot of the writing for our surveillance guides. So yeah, please feel free to reach out and email anytime. Okay, so David says he's used the series beads and they work well. I guess I was wondering if you have a universal extraction method for viral and bacterial targets. And this is also, again, something that keeps me up at night and that we're actively working on because there's going to be some bacterial targets that are quite a bit more stable than others. So what we're envisioning right now is that there's probably going to end up being two workflows. One that involves bead beating of, C. auris and some of the AMR targets. Maybe even Campy needs bead beating. We're not entirely sure yet. And then the other workflow will be more of a gentle, sort of traditional extraction. So greedily, if that's even a word, I was being very greedy at the onset of this work, and I wanted to find one universal extraction method, and it might be out there, but we haven't come across it just yet, David. So if you happen to have any suggestions or thoughts, I can tell you that I would definitely be willing to try it out. So yeah, awesome. Does anybody else have any other questions, comments? Okay. Well, if there's nothing else, I would just like to say again, thank you to you all for taking the time out of your day and attending this webinar. I hope that you've gotten something out of it. If nothing else, feel free to just drop us an email and introduce yourselves. Let us know if there's anything that you can help us out or that we can help you out with. Again, we have logistics services for sample collection. We have our internal testing service. We have the assays that we manufacture and QC and ship. We have surveillance guides. So more than happy to help out. Oh, it looks like David says, we've also been looking for one as well. I think it's interesting that the concentration beads from series or from MagMax kit can concentrate more than virus. Yeah, absolutely. So I was talking to Lauren Saunders at Series just a couple weeks ago, actually, and she said that a lot of bacterial targets do get concentrated with the microbiome A particles. And there's just a subset of bacteria that need the microbiome B particles. So what we envision moving forward is adding in both A and B particles at the beginning so that we can concentrate potentially everything. But again, the question is at that point when we have to split up the concentrate and do extraction by bead beating under one condition and then magmax or Kyogen extraction on another. So yeah, David, please feel free to reach out and let me know if there's anything that you've seen, anything else that you want to for us to try. I would be very interested to hear about your results as well. Okay, let's see. Great. Well, yeah, thank you again, everyone. I hope that you can Enjoy the rest of your afternoon, get a little bit of time back. And again, yeah, I hope that you have a wonderful day.
Thank you, Dr. Kane, and thank you to today's sponsor, Bio-Rad. And thank you all for attending today. You may exit the platform. Enjoy the rest